test first. And then we'll finish up the material for this semester. So one thing that is everyone here? Everyone? Okay, so one thing that made me cry was something like this. I'm just making it up. You are going to give me the problems that you need me to work on. So 2x squared plus 3x minus 2 equals 0. And my wonderful students did this and said that x is probably 0 or negative 3/2. These steps made me cry. If you heard somebody scream last night, I'm kidding, of course. It was me when I read this. So can anyone explain what's wrong with this? Anyone?
Shouldn't be set equal to 2. You need to be able to factor out the answer to make it equal to 0.
Negative b plus or minus b squared minus 4 times a times c, which is negative 4 over 2a. We can't solve a quadratic equation by separating two terms on one side, one on the other, and just factoring something and completely disregarding this and just writing something else. Is that clear, everyone? Well, yes? Do you remember? Okay, thank you. Okay, so is there something that I have to answer on the side? In the group chat, do I have to do anything?
No, there's nobody in the group chat right now.
Okay, so I graded everything. I looked at everything you send me as notes, and also I increased all grades. I gave some partial credit, of course, and I considered something extra credit to help everybody's grade. So, but that was something that we shouldn't even discuss, right? Would you agree? Everyone agrees with this? So please go back through your notes that you send me, and when you find this, just put a little tear. It's from my eyes. Okay, next question. Or anything you'd like me to go back to. Any problem from the test, anything?
I have a question from the test.
Yes, please.
It's related to Newton's method.
Okay.
And solved to 6 decimal places.
Okay.
It is,
I only needed one. If you remember, you didn't need to find both. I couldn't care less what the WebAssign said. Just one. I don't want you to spend time on the same thing twice.
Mm-hmm.
Okay.
It was in parentheses x minus 7 to the second power equals natural log of x.
Perfect.
Correct.
So first we have to determine the function, because solving this equation is the same with solving this equation. We know that, correct? So that's why we call this f of x as x minus 7 squared minus natural log x. We will immediately find f prime, which is 2 x minus 7 and minus 1 over x, because the inner function prime is 1. And we will put this in the graphing calculator, but Newton's method will be x minus. The numerator has to be the function, x minus 7 squared minus natural log x, and the denominator must be 2x minus 7 minus 1 over x. Careful, because this is not defined at 0. I cannot start with x0 being 0. Then I will put it in the graphing calculator because I have no idea where the solutions are, or even the, one solution. It doesn't matter. So ny equals, we put in parentheses x minus 7 squared, and then minus natural log x, close the parenthesis. And then I go to second table, and hopefully I see a sign change because this is a continuous function. I have to write that, right? So continuous on 0 to infinity, because x has to be greater than 0. Here it doesn't matter, but x has to be greater than 0. So so when I plug in, let's say 4, and I see it's positive, and then I plug in 5, and it's still positive, and I plug in 6, and it's negative. So I don't care which solution you determine, but there is one between 5 and 6. So the interval is 5, 6, where I want to find the solution. It doesn't matter which one I start with, because as long as I don't start with 0, because I can't, it doesn't matter. So let's say 5. Then I go back to the graphing calculator. I put this in. Don't erase what you have. You just insert x minus parentheses and parentheses. So in y equals, just second and insert, put x and then minus parentheses, go all the way till the end, and then divide by, in parentheses, 2 parentheses again, x minus 7, close the parenthesis, and minus 1 divided by x, and close the parenthesis. Get out of there completely with second and quit. Go to variables, go to y variable, function 1, and I'll plug in 5. When I press enter, I get the first iteration as 5.569814449. And then I repeat with second and entry, but I have to overwrite the 5 by second and answer. And from this moment on, I don't have to do this anymore. This is one time. So now the calculator will take this number and plug it in the function. So I press enter, I copy again and press enter, copy again, press enter. So I got x1, and now x2 is 5.6776899274. And then the next one is x3, 5.6819299751. And then x4 is 5.6819366245. And I'm assuming we want 6 decimal digits. And that's it. The next one will repeat completely. So if we want 6, I think you said 6, Sean. I'm not sure. So this is, okay, so that's the answer, because the next one repeats completely. All 9 digits. Was this okay?
Yes, thank you.
Perfect. I do have a question. You had some difficulties with that second problem with some rational exponents. And I'm not sure why, because we had those in class, and I thought you had them in homework. So who would like to come up with that second problem? Anyone? I think we're asked to find
critical numbers of the function question?
Yes.
Okay.
The
X,
one with rational exponents.
Yeah, is x to the 1/5 minus x to the negative 4/5.
Okay. Because I think some of you had difficulties with this. Okay, so let's find f prime. So first of all, remember, x cannot be 0. How come? Because this is basically the 5th root of x minus 1 over the 5th root of x to the 4th. I would have presented it like this just to see what's happening here. So obviously, the function is not defined at 0. If I find the derivative, and I will find, it's undefined at x equals 0, it doesn't mean that it's a critical number. It can be a critical number because the function itself is not defined at that point. So do not write x equals 0. If you did, that's incorrect only because the function is not defined. But if you don't change it like this, you may not be aware that the function is not defined at 0. So this is what I would have done first. Just changes for so just look at it. Okay, of course I'm not going to differentiate this. I'm going to differentiate the original. So f prime is 1/5 x to 1/5 minus 1, which is negative 4/5. I bring negative 4/5 in front, so it's 4/5. And x, remember, negative 4/5 minus 1 is negative 9/5. But the whole thing doesn't end there. Okay, so first of all, I see that 1/5 is a common factor. Also, the smallest power must be the common factor. Always. So let's stop for a moment. If I have x cubed plus x squared, I don't factor out x cubed, right? I factor out the smallest of the two, and then I get x plus 1. Same thing here. Negative 9/5 is smaller than negative 4/5. So I pulled out negative 9/5. From negative 4/5, let me write it for you so you can see it. From negative 4/5, I subtract negative 9/5, like I did here. From x to the third, I subtract x squared to get x to the first. So what is this? It's nice, because it's 5/5, which is 1. So in parentheses, I get x. And then, of course, plus 4. Because I took x to negative 9/5 outside, and I took 1/5 outside. So now, this function becomes x plus 4 over 5, the 5th root of x to the 9th. Yeah, you can simplify this into x and the 5th root of x to the 4th. Who cares? It's in the denominator. This is undefined when x is 0, but so is the function, so I don't care. So the only critical number is when f prime equals 0, and obviously is when x equals negative 4. So the function has to be fully simplified, the derivative has to be fully simplified, and remember the most, I shouldn't say the most, but very, very important keywords that you should always, always keep in the back of your mind. In any math class, factor, and the other one is simplify. Without factoring, I would have had difficulties here, potentially, right? Because I see negative exponents, ugh. So, but if I factor out the greatest common factor, which must be x to the smallest of the two powers, like in this case, and then all I have left is just x plus 4. And that's how I get the solution, as being the only critical number, x equals negative 4. Is this okay? Do we have other questions from the test? Anything else you would like to work on?
I have one other question from the test.
Please. But are the steps clear now? I cannot stress enough, we're down to 2 weeks. Please, for me, test 1, test 2, and test 3, redo them in the next 2 weeks, maybe at least 4 times each. And then you will be super prepared for the final. Of course, not everyone needs to do them 4 times. You know, this is a suggestion. You're going to fine-tune that based on your, how strong you feel already. But I would do them as many times as I need to. Sorry, Sean. Yes, I'm ready. Sorry.
It is a question related to Rolle's theorem.
Yes.
Find all numbers for C, satisfy the theorem is f of x equals x to the third minus x to the second minus 20x plus 20 in between 0 and 5. Correct.
Perfect. Okay. So I think that this is 3 and this is 4. Okay. So first of all, I have to write that, number 1, that f is continuous, and I know it's a polynomial. Then I have to write, of course, on 0, 5. It's continuous everywhere, it's differentiable. So f differentiable for the same reason everywhere, but at least 0, 5. And I need to check the third hypothesis. I need to find f of 0, and I need to find f of 5. F of 0 is 20. F of 5, 125 minus 25 minus 100 and plus 20. So this is 100 minus 100, and it happens that it's 20. So therefore, all 3 conditions are fulfilled. So now, by Rolle's theorem, there exists a C between the interval 0, between the in the interval 0, 5, such that f prime of C is 0. So I have to find f prime, and f prime is 3x squared minus 2x minus 20 equals 0. That's our f prime, 3x squared minus 2x minus 20. And yes, if I replace it by C or not, it doesn't matter. And that's what I'm talking about, negative b plus or minus b squared minus 4ac 12 times 20 over 2a. I plug in the calculator. 2 plus the square root, in parentheses, 4 plus 12 times 20. I could have done that myself. Close the parenthesis and divide by 6. So I get that C. Now, if they want it as an exact, so maybe I should stop for a moment. If they wanted the answer as exact, which is very possible, what is this? So this is 244. And 244, if I divide it by 4, it's 61. Okay, yes, probably they want the exact answer. So then I'm not going to approximate. So we have C equals 2 plus or minus the square root of 244 divided by 6. But 244 is 4 times 61. So then C will be 2 plus or minus 2 the square root of 61 divided by 6. Do not simplify like this. You have to factor out 2, 1 plus or minus the square root of 61 and divide by 6. And this is your final answer if they want it exact. So C is 1 plus the square root of 61 divided by 3, or minus. But remember, it has to be between 0 and 5. Not both solutions are between 0 and 5. Only 1 plus the square root of 61 divided by 3. And you can always check to make sure. So the square root of 61. And then plus 1, and divide the whole thing by 2. I'm sorry, by 3. And it better be a number between 0 and 5, and it's 2.9. But they don't accept this, but I gave full credit for writing that 2.9 instead of this, but this was what they wanted, because they were asking us to put in the simplified, non-approximated. Is this okay?
Yes, it is. Thank you very much.
Thank you. Next question.